Last time we looked at how you find double integrals over rectangular regions. So now we're going to look at how to find double integrals over non-rectangular regions. And I gave you a kind of warm-up, didn't we, with a triangle last time? So kind of we're going to look at questions similar to that, but more difficult as well. So first one I'm going to do is already set up. If you're being asked, I'm going to put everybody on mute. I'm getting some kind of weird feedback thing. So as always, you'll have to hit the space bar to answer a question and so on. Okay, here we go. This one's set up. We're going to evaluate y from 2 to x squared. And we're going to do x from 0 to 1. And this is going to be the function. So this would be the function that's floating above. And then below it, there's this region. So if you wanted to know what this is, you don't need it for the question, of course, but you could probably construct it. X goes from 0 to 1, and y goes from y equals 2 to y equals x squared. So if you imagine this is y equals x squared. So you're going to create a region that's made up of these two guys. What would that look like? Oh, it'd be a crossover. I guess it would be that weird shape. Don't need to know it to do the picture. I'm not really convinced I drew a good picture, so I'm going to make it go away. Because we know how to integrate. You do it in 2 stages. You always do that step first, right? So we're going to integrate with respect to y. xy integrated with respect to y will give you 1/2 x y squared. Comfortable with that? The number 1 integrated with respect to y gets me y. We then evaluate the y, not from one number to the other, which was yesterday, but from one value of y to the other, where at least one, if not both of them, are in terms of x's. And then once we've figured that out, we can then integrate the answer with respect to x. So let's see what we get. Plug in x squared, so you're going to get 1/2 x squared squared plus an x squared. Take away a whole load of nothings. And 1/2 x squared, that's 4, that's 1 more is 5, so I get 1/2 x to the 5.
Why would you be taking away 0? The second value is 2.
Oh, 2. Oh, let's change the question so I don't need to. And now we are left with, if we do it correctly, shouldn't we be left with a Calc 2 integral? And of course, you might have to do the power rule, that's the easy one, which is exactly what I would do here. But couldn't you sometimes have to do a U sub in a different world? Maybe even a integration by parts now and again. And in this case, increase the power by 1, divide by the new power, increase the power by 1, divide by the new power, evaluated at 0 and at 1. That gets me 1/12, add a third. And that just gets me a whole load of zeros again. That's 4/12, so that's 1/12, so it looks to me like the answer is going to be 5/12. Does that seem reasonable? Now, in many of these questions, we are visually interpreting this to represent the volume underneath a surface directly above the XY axis typically, right? Going this way. And that works fine. But can I tell you, it is possible to get a negative answer to these calculations. So if you're thinking about what the heck is a negative answer, can you imagine a shape that goes not just above the XY plane, but could be below the XY plane? So a negative number in that context could just mean there's more volume below the XY axis plane than there is above. The analogy is, remember when you did Calc 2, couldn't you have the area under a curve being negative numbers, and that was fine? So trust the math. If it says it's negative 5/12 and you haven't screwed up, it'll be the right answer. Not all of these double integrals is it helpful to think of them as volumes. Sometimes it's just better to think of it as being a calculation involving integration of a three-dimensional function. And what that might be is, that might not represent volume. It might represent the total magnetic force inside a region, or the total energy inside a region, or something else. And maybe if you thought of it that way, you would get a better feel for what you were doing. So trust the math and you are good. Do one more where it's already done for you. Right. So I'm going to do an integral from y equals 0 to y equals pi. I'm going to do an integral from x equals 0 to x equals sine x. And I am going to do 2x plus y squared. Not that you would probably need to do this, but just for curiosity. If you know these two, don't you know the order of integration? Who should go first? Who should go here?
X.
Right. Just saying that because later on when you construct your own, you got to be careful you do the x's with the x's and the y's with the y's. That's why I do this overkill thing here. It kind of keeps it in my brain. If these are just 0 to pi and 0 to sine x, you sometimes accidentally switch the order, or you integrate with y's when it should be x's. So this is good. So it's going to be an integral from 0 to pi. And let's see what we get. That guy is going to get me x squared. That guy is going to get me y squared x. And it's going to be from x equals 0 glad I fixed that in the last minute. X equals 0 to x equals sine y. Let's see what we get. The integral from 0 to pi. If you plug in sine y for x, you get sine squared x plus y squared
Shouldn't it be sine squared y?
Yeah, sine squared y.
Thank goodness somebody's paying attention. Yes. I was pausing because I knew it wasn't right, but I couldn't see what the heck I did wrong. Take away. Oh, great. Can we get a whole load of zeros at least for the other piece? Right. So I'm just writing this again because it's a bit messy. And I'm going to be doing a dot, dot, dot in a second, mostly because of time. I need to integrate this fella. Now, it's nice when it's y cubed. It's a power rule, but you don't expect every integration to be a power rule. We need to find that guy from 0 to pi, agreed? And we also need to find, and I'm separating them out because the two questions are going to be done quite differently from each other. So I'm going to get that answer, I'm going to get that answer, and then can you imagine we just add them together and we're done? So sometimes you have to split things up because they just don't play well together. Right, how are you going to do this, fella? The integral of sine squared y. You need a technique to integrate this guy.
Integration by parts.
Call it sine y, and make one of them f and the other g. Fortunately, it works sometimes, but not this time. So give me a different technique.
Are you able to look trig sub for this one?
Yep. Do you know what the trig sub is? Oh, trig sub. Let me rephrase that. Not trig sub, trig identity. Yes. Do you know that sine squared y can be written in terms of something else? It starts with a half. Can anybody fill in the missing piece? Sine squared y is a half of
1
Was
minus
it
cosine
sine
2y.
cosine?
yeah, 1 minus cosine of 2y. So it's going to be 1/2, take away 1/2 the cosine of 2y dy. So can you imagine doing that the usual way? And that's just going to get you half y, isn't that going to get you eventually -1/4 sine of 2y, but you can do it as a u sub if you prefer. Right, how about this fella? What technique am I going to use to do this guy?
Okay, that one's integration by parts.
Correct. So you are going to have to brush up on your techniques of integration. You're going to have to do some u subs. You're going to have to do some trig changing like we did here, trig identities, and you're going to sometimes have to do an integration by parts. And of course, you're going to do the power rule. Out of that set, I don't think the power rule is a problem, right? It's the other things that are going to cause you all the issues. And that's a fairly long, complicated question, right? But it will work eventually. If you do this, do you know you have to do integration by parts twice before you finally get the answer? So you have to repeat integration by parts and then do it one more time, and that'll get you the answer. So pretty heavy duty fighting your way through things. Okay. Now, let's look at a non-rectangular region. And I'm not going to do the whole question. Let's just focus on how to set up, you know, the R equals the set of all x, y, such that, and then you put in two constraints and that kind of thing. How you set up the limits of integration when it's not rectangular. Well, I guess for completeness sake, I'm going to put a rectangular one in anyway. Suppose that the region on the floor that you're going to then go upwards to meet the surface and calculate the volume. Let's suppose that it's a rectangle that looks something like this. 1, 5, 1, 2. That region we call R, right? That's the typical naming for it. Would you agree in this region, you're going to do x equals 1 to x equals 5, and y equals 1 to y equals 2. And then you're going to have whatever the function is, which we're not getting into that. And won't you do a dx, dy, at least the way I've written that one up. You see the x's match the 1 and the 5, and the y's do the 1 and 4. Would it be okay in this question to switch the order of integration and the limits of integration? Would that also get you exactly the same answer as the one above? So when it's rectangular, there's really no preference. X first, y second, y first, x second. Suppose the region that we're interested in is this red region. The function is x cubed. And this is 0, and this is 2. Now I want to set up the guy. Now, in this question, there are options. You might not think it, but there are options. One option tends to generate a nice integral that works. The other option tends to generate an uglier integral that also works. So I'm going to do the vertical rectangle trick. Can you imagine that being a random point from here to here, right? And that's at position X. Now, if I wanted to represent this region, wouldn't X start at 0? And wouldn't X finish at 2? So can you imagine the little rectangle starting here and then going to the end? Wouldn't all those rectangles from X equals 0 to X equals 2, if you put them all together, wouldn't they represent that shaded region? Now, what do the Y values look like? Well, the Y value is 0 at the bottom. But won't the top depend on where the rectangle is? And won't the top be X cubed? And now I have set up my integral. Now, if you do this right, shouldn't the outside be numbers and the inside are variables, typically, right? You will never have a X equals 0, X equals Y out here. If you do, it's just wrong, right? It has to be two numbers. The inside one, which I'm calling this one here, that can and very often will be, especially in non-rectangular regions, won't at least one, if not both of these have X's in them in this case. So that integral, that's the double integral that would work for this shape. I'm now going to look at this shape. I think I'll draw it in a separate piece of paper because that's got a bit of mess in it. And I'm going to look at it not from the X going vertically upwards orientation. I'm just going to look at it now. Since this guy is X cubed and this guy's 2 and this guy's 0, isn't this guy up here 8? Comfortable where the 8 came from, right? Now, if I wanted to do this rectangle, but I'm now going to orientate it this way, won't the Y be 0 all the way up to 8? You see those horizontal rectangles would create the shape. So I know that Y is going to 0 and Y is going to go to 8. And now I need to figure out what the X's are. And I'm doing the X's first and the Y second. So it's the same region. In this case here, won't the X finish at a 2? Now, what's this guy going to look like? Well, this guy has to come from here. But if you rearrange this, isn't X the cube root of Y? Right, if Y equals X cubed, isn't X the cube root of Y? Do you see the connection between the two? Now, in that case then, won't this curve be X equals the cube root of Y? This fella will do the exact same job that this does. I would say, based on what I can see, but although I don't know what the function is, wouldn't this one probably be a little bit easier to deal with because X cubes are easier than X cube roots of Y? But you do have a choice. So if you have a region and you want to discover the limits of integration, you can do the vertical ones, that's these ones, where the X's slide from here to here. Or you can do the Y ones, where the Y's slide up and down. If you do the Y ones, the numbers on the outside will be Y values. If you do the vertical ones, won't the X's be the outside number? Now, although you can theoretically do either direction, there are some circumstances where one of them is just naturally the best way to do it. So here is a region that we're going to integrate, and it's going to be Y equals X squared, and y equals the square root of x. And the region that we're being asked to integrate is that little eye-shaped thing. So let's set up the limits of integration. In this question, just because the way the functions are written, would you agree that it's probably going to be easiest? I think I'll use green. Oh, by the way, that's 0 and that's 1, right? To do the vertical ones. Now, if I do it that way, won't the x go from 0 to 1? And what will be the y range? Right, if you take this one rectangle, what's the tallest part? Well, the tallest part is this curve. So y equals the square root of x. And the bottom one is y equals x squared. And because of the order that we've created this, you see it's dy first, dx second. So we're just doing a skill building exercise of generating the thing. I would say this one is pretty much the natural way you would tackle it. But let's suppose that you're a contrary kind of person. Let's see if it is possible to do this same region Let's go that way. Well, there's one major difference here. Aren't these two equations, the ones that were given, say, in the question, designed for y equals? So don't we have to recreate them, rewrite them in x equals a function of y? And by sheer symmetry, don't you get those two guys? Now, since I'm going horizontally, the y values are going to go from 0 to 1. I think I should have picked a better question here, but too late now. And what's the x is going to look like? Which one of these guys comes first? Well, isn't it always the one the furthest to the right? Right, that's the top number. And the furthest to the right is x equals the square root of y. And the other one is x equals y squared. And the function xy dy dx. This guy will do the exact same thing as this guy. I can actually, now I'm thinking about it, I can imagine a situation where maybe this would be easier to do. It depends on who f of xy is. See if f of xy had a whole load of x's in it and very little y's. Or the opposite, a whole load of stuff with y's in it, but very little x's. Can you see that one of those integrals might be less work than the other?
Isn't your dy dx backwards?
Oh, I did. Thank you. Yeah, I just wrote that down. X's, y's, right? That's the order. So I'm just saying you can imagine that you could do that. So let's return back and look at finding a double integral over a non-rectangular region. Now, I'm just going through the homework questions here. Okay, let me wind back a little bit. Let's do one more preset one. I just saw a question that's probably going to cause issues. S equals 0 to s equals 1 of the integral of t equals 0 to t equals s to the 7. And the function is the cosine of s to the 8 dt ds. Right, so you didn't need to create this. The question basically did it. The only difference between me and the textbook is the textbook just says 0 s to the 7 and 0, 1. I like to put in the labels. Right, if you take this function and you integrate it with respect to t, you actually get basically that where t attached to it. So it's t, the cosine of s to the 8, evaluated at t equals 0 and t equals s to the 7 ds. And what does that become? Well, if you plug in s to the 7, you get s to the 7 cosine of s to the 8. Take away a whole load of nothings. Right, that's a Calc 2 question. And the reason I didn't want to skip by this one, I just realised that we haven't done an example quite like this yet. What strategy are you going to have to use from Calc 2 to find this integral?
U sub
Correct. Who is your U sub?
s to the 8.
Agreed. You all cool with that? For some of you, it might have looked like an integration by parts because it's got a power and a cosine, and sometimes that is the case. If it was going to be integration by parts, it would have to look something like this. Right? Just a cosine, not a cosine squared or a cosine cubed. And that's the difference between a U sub and an integration by parts. If you choose the wrong method, like you do an integration by parts, but it should have been a U sub or vice versa, normally you know after a couple of lines of working that it ain't working, right? It's getting uglier and uglier, it's not getting nicer. Or there's a bit left over that you haven't a clue how to fix. You know, there will be clues to the wrong method. And I guess it's like Sherlock Holmes, right? You know, once you've eliminated all the things, whatever left must be the answer. So once you've eliminated all the techniques that don't work, whatever's left must be the only one that does work. And we have a limited choice. Power rule. I've got a good memory. That just means I happen to know what the integral of sine x, cosine, right? All the standard integrals. U sub, integration by parts. Technically, there's a one called the x sub. Do you remember the trig substitution? X equals sine theta, that kind of thing. But you're not getting any of those questions, so I'm not going to lose sleep over going over a situation that hasn't happened. Okay, now I can go to what I was going to do. Let's look at creating an integral. And here's the story. The non-rectangular region is y equals x take away, 42. It is 42, cool. And x equals y squared. And we're being asked to find the double integral over this region. Well, for some reason, they're calling it d instead of r, but that's no big. Of y dA. So we've got a lot of construction to do. We got to figure out what does this look like, and I think you have to kind of do it visually to see what the heck's going on. I'm a bit surprised about the 42, which is nice. X, what would x take away 42 look like? It'd be a line like that, wouldn't it? You could use Desmos to figure it out. X equals y squared. X equals y squared. Now, when you do x equals y squared, No, I don't know why I'm writing it twice. So they're talking about this region, right? Now we know who D is. A straight line meeting up with an x equals y squared. Now, do you notice that one equation is the form y equals a function of x, and the other one is x is a function of y? I got to decide here, do I want to go x's, do I want to go y's? Do I want to go vertical, or do I want to go horizontal? If the way you decide that, if both work, it's fine, right? But the way you decide that if only one is going to work is, imagine random vertical lines. Isn't everything fine until I hit here? That means vertical lines ain't going to cut it. Can you see in this question, if I do horizontal ones, one I always start at one and finish at the other. One I always start at the straight line and finish at the curve. At the end, at the middle, and at the top. So that tells me right away that the version that I'm going to be doing is the one that has x equals. So if you rearrange this guy, isn't x just the same thing as this fella? Now, for this shape, one rectangle, this rectangle here, isn't it straight line first and y squared second? The function is y, and I'm doing the dy's, and now I have to do the dx's. And
Professor, you wrote y equals
I
y squared?
know. Now I need to do the x's. And now I need to do the y's. God. I write the thing down and I don't pay any attention to my own rules. Let me pretend I never wrote that and I'll start again. We had everything set up. I just made a meal of it. I need to know the start and finish, right? These two numbers here. And they're going to go, once I find out what they are, they're going to go here. Then we do the x's, which we did get correct. The straight line is the top one. And the other side is the curve. The function that we're being asked to do it to is y. According to this, I'm doing the x's first and the y second. Would you agree I've almost set everything up? Now, what is missing? Well, isn't these two y values missing? I need to know y equals -2 to y equals 4. And I need to figure out what they are. Now, if they're nice numbers, won't you probably be able to look at Desmos and you can just scan across and see them? And if the numbers are -2 and 3, that's great. But let's pretend that they're not. Then wouldn't I have to take y plus 42, which is the straight line, and match it up with y squared, which is the curve? And then if I rearrange that, I get y squared, take away y, take away 42. And I believe this factors, and it factors as a 7 times 6, which means that the top number is 7 and the bottom number is -6. So that guy is -6 and that guy is 7. Are you comfortable where I got those two values? But if you had Desmos, they're such nice numbers, you could probably read them off. So I'm going to go from -6 to 7. So far, so good? Okay, let's see what the next thing has in store for us. Let's do this guy. If you integrate y with respect to x, don't you get xy? Right, if you take y, integrate it with respect to x, you get xy. You're going to evaluate it at x equals y squared and x equals y plus 42. That's going to be the integral from -6 to 6, x times x times y, take away x times y. this fella, and somehow or other, that number gets changed. This fella, I'll list it again. Distribute all this and let's see what we get. I get a y squared, I get a 42y, and I get take away y cubed dy. And we're going to do it from y is -7 to 7. And can I dot that because it's just basically calc 2 power row. So back to this question. You really need to use your Desmos to see what these darn things are. Because if I didn't have this picture, couldn't I, if I tried to just do it algebraically, couldn't I set up an integral that actually wouldn't do the job? I might have decided that I was going to set it up in terms of vertical rectangles, not horizontal ones. And we can see that the problem with that would be, you know, here and here, for instance. So here is an example where only one choice is actually going to come out and work.
So what would happen in case of a circle?
Where is the circle going to be? In the center or off center? Where are you thinking? Over here somewhere?
Why not?
Okay, so you have a circle here, like that. So it might be called x minus 2 squared plus y squared equals 4, you know, something like that. Right, suppose that was my region. Right, if I'm looking at vertical or horizontal, I have to realize that this circle can be thought of as a top bit, take away a bottom bit. So I would just rearrange this equation, probably something like this. Yikes. The positive version of that guy would give me the top, and the negative version of that guy would give me the bottom. So if I wanted to do vertical rectangles, I would do the integral from x equals 0 to 4. I do y equals negative ugly square root to positive ugly square root of whatever the function was. I do the y's first and do the x's second. And then we hope to God that this function has got some square stuff in it so that these things stop being square roots. Okay, that would be how you would tackle that. We go. Any other questions for, we're still doing lots of these guys because there's a lot of meat in these, right? A lot of things you have to be able to see to get comfortable with. Okay, I'm basically just using the homework to scroll through because it makes it easier for me to figure out what to do.
You want us to take attendance then?
Oh God, time. Yes, you want to do attendance for a few seconds? I'll give me a chance to set up my next question. Okay, 26. What's that come out to be? Ooh, that's not good. 8 people missing today? Okay. There's 2 more. 6 people missing today. Come on, if you're here, hit that here button. Okay. We've been asked to find this double integral, x squared plus 2y over a region, dA, or over a region D. dA is just a placeholder. It's made up of these 3 things. I could probably do this without needing Desmos, because y equals x is easy to draw. Would you agree that y equals x cubed looks something like this? But since x equals 0, aren't we only interested in this little guy? So we need to set this thing up. I would think that the way this particular one is working, would you agree vertical rectangles are going to work fine? So if you imagine a kind of random vertical rectangle here, that tells me that the x is going to go from 0 to 1, and that the y values are going to be from a straight line to the curve. So straight line to the curve. The function is x squared plus 2y. We're going to do the y's first and finish with the x's. Are you comfortable about how I set this one up? Could I do a horizontal? Sure. Would I probably be giving myself a lot more work? Yeah. Would it be wrong? Nope, because you get the same answer at the end of the day. But most people like to do things easier. If there's a choice and one's easier, we like to do it that way. Agreed? Now, can I just skip by this bit? Because can you tell this is just going to be a big polynomial? Just going to be a power rule. Replacing these guys, it's just going to be a really big, ugly x6s and 4x cubes and whatever, and then another power rule to get the answer. Here's a different question. It's not what they gave you, but can you imagine it wasn't, that bit was missing? Then technically speaking, aren't there two distinct areas? And if they wanted you to integrate this, do you know that what you would have to do is actually split the question up into doing this guy, which we've got, and then wouldn't you just set up a similar looking one for this guy here? But in this case, wouldn't they switch places? Because if you do the rectangle this time, won't the x cubed be high and the x below, right? Top, bottom. So that's what you would have done if that was missing, right? Just like, have you remember when you did Calc 2 and you were doing an area under curve and there was a crossover? Wouldn't you do the top bit and the top right and the bottom left as two separate ones because they switch places? You know, top, bottom switch with the other one. Same thing's true here, right? A lot of the skills that you brought from your Calc 2 world kind of still work here. You just have to adapt. So I think I should finish with a joke today, because the next question I was about to do will take more than 4 minutes. So are you ready for my joke?
Go right ahead.
God, it sounds like someone's about to receive the punishment. Okay, just get
I'm
ready.
enthusiastic.
See? Even if it is fake, that's what we want. Okay.
The joke is so funny, I'm going to laugh early.
Oh, God. Ooh, that's painful. Right. So a way back in the day, the Olympics were held in China. And there was a Scotsman, an American, and a Polish guy. They were all friends, and they turned up and they wanted to go to the opening ceremony. But I mean, those kind of tickets were sold out like years ago. They had no chance. And they're sitting outside in this construction site, just waiting to figure out how they're going to sneak in. And it looks very difficult. But the American says, I've just noticed there's a little door at the side there, and it's just one security guy. I think we can con our way in. And the other two says, well, how are we going to do it? He says, just look at what I do and kind of follow the lead and you should be fine. So the American guy looks around and he sees a big hammer and he puts it on his shoulder. And he walks over to the door where the guard is and he goes up to him and he says, American athlete, hammer thrower. And the guy looks at him and thinks, oh, okay, then in you go. Scots guy said, that was easy. And he looks around and he sees a big scaffolding pole. Puts it on his shoulder and he walks over to the door and the guy's there and he goes up to him and says, Scottish athlete, pole vaulter. The guy looks at him and says, aye, okay, in you go. So the Polish guy's looking round and round and he finally sees a roll of barbed wire. Big roll of barbed wire. Puts it on his shoulder. Goes over to the door. Goes up to the guy and he goes, Polish athlete, fencing.
Wonder what happened to him right after that.
Oh, come on. Leah, I like you couldn't help it. That one hit your funny bone somehow, right?
Yeah, that was a good one. I
Okay.
like that one.
Okay, guys, that's going to have to be us for today. So you're getting a 2-minute break. Well, 2 minutes of joke and a 2-minute break. Try and get started on these things because some of them, you know, especially the ones that have power rules in them, not power rules, integration by parts in them, you know, it could eat up 20 minutes on one question very easily. So you don't want to get, you know, too far behind. Okay, I'll see you all tomorrow. And with a bit of luck, we'll finish these.